we are almost finished with chapter 6. Guys, just as a reminder, if you would like extra credit for your chapter 6 test, those 4 Edgenuity quizzes, what you need to do is you need to make sure that all of your IXLs are done by today midnight. Okay, today is Thursday, so today midnight. All right. So we finished our last lesson. Hopefully you just submitted your notes and your level work onto Schoology. Guys, remember, start this quarter off strong, okay? Because remember, if you're not turning it in on time, then it's a 0, okay? So it's either a 0 or 100. And trust me, those zeros actually add up and they pile on really quick, okay? What we're going to do is just kind of a review to just put, chapter 6 all together. So we are going to, the 2 most important things from chapter 6 was probably exponential growth and decay, and then negative exponents. Remember flipping it if you have a negative exponent. We're going to go over it a little bit today because I'm sure some of us have forgotten. So this is the review that online kids, I need you to download, and then you can write it through Kami or print it out. This is the review that all of you have in front of you right now. Okay, so that's what we're going to go over, because after I go over this, you are going to work on 2 Edgenuity assignments. I believe they're just 10 questions each. They're just 2 Edgenuity assignments, and that's it. So Edgenuity assignments are different than Edgenuity quizzes, okay? Assignments is just going to be a daily grade. It's not a test grade. It's just a daily grade, and you just get the grade, okay? So if you get like an 80 on an assignment, then you get an 80 in the grade book. There's no retakes either, all right? So please make sure that you realize, since it's just a daily grade, you only get 1 try. So let's go ahead and do that. Online kids, do you have any questions? Can you see the thing now? Okay, so let's do maybe the harder one first. Okay, so go to the side that says Thursday 1.7. For synchronous time, we are going to do the assignment review. Here's one assignment, 0 and negative exponents. And then the other assignment is right here, exponential growth. Okay, and then for asynchronous time, you're going to just get the 2 Edgenuity assignments done. If you don't finish, then you are going to finish it for homework. But I would hope that in class, you can at least finish one of the assignments, so you only have 1 left to do. Okay, and that's all we're doing today. So let's practice. So 0 and negative exponents. Maybe before I do any of these questions, let's just remind ourselves, if you have a negative exponent, you have to flip it, right? So that was the rule. If ever you have a negative exponent, you have to flip it. So like 7 to the negative 2, remember that would actually just be 1 over 7 squared. Does that ring a bell? Like negative exponent means you have to flip it. Since it was on the top of the fraction, now it goes to the bottom. So you just flip it, and now this is simplified. So like if I left my answer as 7 to the negative 2, that would not be simplified, which means that I need to make sure that I flip it. Flipping it would ensure that it's simplified. And the negative, remember, just turns into a positive. Okay, so you're going to see a question like this on your assignment today. So it's going to say like, okay, I have 1 over negative 3 to the 4th, and they're going to expand it. They're going to say, well, that's the same thing as saying negative 3 times negative 3 times negative 3 times negative 3, right? Because it's negative 3 4 times. Now, take a look at this problem. Do I need to flip it? No, because there's no negative exponent. There's a negative base. Remember, the base is the big number, but the exponent is positive, so I don't need to do any flipping. So your question on the homework today, or the Edgenuity assignments, can be just what's the value of x? So all of this equals that. So just figure out what that number is. So I think the biggest mistake you're going to do, because it's all calculator work, right? Just put it in your calculator. The biggest mistake you're going to do is it positive or is it negative? I think that's the biggest mistake you're going to make. So why don't you try to figure it out first? You decide what you think it should be, and then we'll talk about it. So definitely, yes, you need your calculator today. Okay, someone in person, do you think you know what the answer is? What is the value of x? Tessa?
81.
81. Is it 81 or negative 81? It's just 81, right? A negative times a negative times a negative times a negative, that's an even number, is a positive. So for some of you that were like, no, it's negative 81. Look, I typed it in. No, it's not because you forgot the parentheses, right? Parentheses make all the difference. If it's a negative, you have to make sure that you put it in parentheses if you saw it there already. And so that's why Tessa is right. It is 81. Another mistake that I feel like you're going to make is you're not going to read carefully. You're going to say the answer is 1 over 81 because that's the whole answer. But they're not asking for the whole thing. They're just asking for the denominator, right? So what's the value of x? Just the denominator. So it's just the 81. Okay. Next one, simplify 2 to the negative 3. All right. So you have a negative exponent. So hopefully you remember what to do. Flip it, yes. All right, someone online, do you think you know? What's my next step?
You flip it?
You flip it. Okay, so what does it look like then if I flip it?
One over 2/3.
Yeah,
Or
1
2
over 2
to
to
the
the
third.
third. Good. Right? You just flip it. Since it was on top, then it goes to the bottom. And since you flip it, after you flip it, you don't need the negative anymore. So I think that they're probably going to simplify it even more just because 2 to the third is a small answer. So 2 to the third, that just gives me 8. So it's 1/8. My final answer after I simplify it is 1/8. Okay. Next one. Simplify. So remember, negative exponents flip, positive exponents stay where they are. So start moving things around. Does anyone think they remember this one? Cameron?
Y2 over x to the third and then z to the fifth.
Perfect. Okay. Negative exponent, the x has to be flipped, so it goes to the bottom. Positive exponent y, so it stays where it is. Z, negative exponent, it flips, so it goes to the bottom. You can't simplify this anymore, right? You can't like subtract or cross out any of the exponents because they're all different bases. They're different letters. You have a y and an x and a z. If you had the same letters, you could simplify it even more. But right now, since they're all different, you can't. Okay. This one you're going to see on your assignment, and I feel like you might be a little confused because of that negative, and then it just looks messy. Okay, so let me remind you again what to do. Okay, first of all, if you have a negative in a fraction and it's in the center, that's kind of unhelpful. So the first thing you're going to do is you're going to put the negative on one of the numbers. Does it matter which number you put the negative on? No. So normally I just like to put it on the top because whatever, I don't know. So I'm first going to put the negative somewhere. If you want to put it on the bottom, that's great. If you want to put it on the top, I don't care. Just don't put it on both because if you put it on both, then it cancels out, right? So just put it on one of them. And I'm just going to choose to put it on the top. So now what I can do is I can distribute the -2, right, to the numbers in here. So really, to get rid of the exponent, I have -2 to the -2nd power, and then I have 5 to the -2nd power. Did I do something wrong? I can flip it later, but did I do something wrong before I flipped it? I did do something wrong. What am I forgetting? Parentheses around the
negative.
Yeah, parentheses around this -2, right? Because this -2 was originally in these big fat parentheses. So you have to remember to keep it in parentheses because remember the difference, -2 to the 2nd power, and then -2 in parentheses to the 2nd power, you get completely different answers. Okay, so parentheses do make a difference. Okay, so now as someone said, now we flip it. Negative exponents mean we flip it. So the -2 in parentheses gets flipped because that was a negative exponent. And then the 5 gets flipped because it was a negative exponent. Okay, So final answer is what over what? Thank you. 5 squared is 25. Negative 2 squared. Negative 2 times negative 2 is positive 4, right? There's a parentheses there. So it's positive 25 over positive 4. You cannot simplify that fraction. If you really want to, you can change it to a decimal, 6.25, because it's not repeated, whatever. Okay. Next one. I feel like we've forgotten. Anything to the 0 power equals
1.
Good. Thank you. So many people still want to say 0. 1. Anything to the 0 power just always equals 1. Just don't forget. Okay. Last one of this assignment before we go to the next assignment review. So for this one, I have negative 2 to the negative third to the negative fifth. What's the first thing you think I need to do? Multiply what? Yeah, multiply your exponents, right? You're basically just distributing the negative 5 into here. So if I do that, now I have 2 to the positive 15. Negative 3 times negative 5 is positive 15. I'm not sure if the assignment will ask you to leave it as 2 to the 15th or write it as 32,768. I think they'll probably say like, leave it in exponential form, so 2 to the 15th, or they'll say write it in standard form, 32,000. Okay, so that would be my answer. So just remember, don't do any flipping until your outer exponent has been taken away. Okay, so that's the first Edgenuity assignment you're going to do. 10 questions. Any questions with that? The biggest thing to remember, guys, is if you see a negative exponent, you have to flip it, okay? If you leave it as a negative exponent, that is not simplified. You can't leave anything with a negative exponent. It's not simplified. Okay, let's go to the back side then. Exponential growth functions. So my equation for exponential growth is going to be y equals a parentheses 1 plus r to the t. So just to ring a bell, that's what my equation is. So what does each variable represent? So a, what does that represent, guys? Yes, Reed? The initial value. The initial value means how much you start off with. What is your starting amount? It could be your y-intercept. That's the same thing. But normally people just call it the initial value. Good. Okay. The r, yeah, your rate of change. So I'm just going to write rate. But remember, you write it as a decimal. So when they say, 2%, you write it as 0.02. Okay, don't write 2, it's 0.02. Or like 115% is 1.15. And then T is your time, but it is counted in years. Good. Your time is always in years. Okay. So one of the questions on your assignment, they're going to give you a picture like this, and they're going to ask you 2 questions. What's the multiplicative rate of change? And then the other question is, what is the initial value? So maybe you should think of it like this. Okay, so for the multiplicative rate of change, they're basically asking you, what's the pattern? If I had like a chart, what would the pattern be like? Times 3 times 3 times 3 times 3 times 7 times 7 times 7 times 7. Like, how is it changing from one point to the other? So I would say the biggest thing you probably need to do is look at the points, look at the numbers. Does anyone have any idea maybe what the answer is or how to figure it out? Emily?
Is it like a slope? Do you do the rise and the run?
So you're very close. A lot of people do want to do rise over run, but you can't because it's not a straight line. Yes, Tessa?
Can't you just divide 2 by 0.8?
Divide 2. Yes. Okay. So this is what Tessa's saying. Hey, do you see how, like, if I were to take this, these would be my y's, right? So I go from 0.8 to 2 to 5 to 12.5. So you don't have to draw this table, but this is kind of what I'm like explaining for those of you who like have no idea what Tessa or I am talking about. Like you went from negative 1.8 to 0 to 2 to 1, 5 to 2 and 12.5. That's essentially what this picture looks like if I were to change it into a table, right? So Tessa's just saying to figure out what the rule is, don't I take the second number and divide it by the first one? So 2 divided by 0.8 gives me 2.5. So it looks like that's what I'm multiplying by. That's my rule. My rule is times 2.5 times 2.5 times 2.5. Fun?
Why are we looking at the line?
Because if this were a sequence, wouldn't your y's be like, wouldn't it go 0.8, comma 2, comma 5, comma 12.5? That's like kind of how we saw it yesterday. So you're looking at the y's because that would be your first term, your second term, your third term, your fourth term. And that's kind of how we graphed it yesterday too. Does that make sense, Lon?
Yeah.
Okay. So you just want to see how you changed, how your y's changed from one to the other. So remember, to figure out how you change, you always take your second number and you divide it by your first. So take your second number. You can even take 5. Take 5 divided by 2. Or take 12.5 divided by 5. Okay, so that's your multiplicative rate of change. How much you multiplied by, what's your pattern? So it's 2.5. So then it asks here, what is your initial value? So your initial value is the A. It's the same thing as how much you start off with. Someone online, do you think you know? What number here is your initial value? Anyone online?
2.
Yeah, right? Do you see how your initial value is basically your y-intercept? Your y-intercept, what do you start off with? 0, comma what? 0, comma 2. So that's your initial value. Okay. So how would the appearance, so how would it look? How would the appearance of an exponential growth function change if the A value was increased? So initial value is your A. So if this initial value was increased, if it got bigger, how would your picture look? Read.
The y-intercept would be higher up on the line.
Yeah, like your whole picture would just move up, right? Does that make sense? If A stands for initial value, and initial value just means y-intercept, it's asking if your y-intercept moved up, how would your picture change? That means your entire picture would just shift up. So the y-intercept would move up with your whole picture. So your entire y-intercept, if it gets bigger, that means your whole picture just gets maybe a little bit taller. Okay, 2 more. Write the function of this situation. Okay, Bob starts with $50,000 and his salary increases by 135% each year. So remember your original equation? Let's start filling in the numbers. So you have y equals A. What is A?
50,000.
50,000. Right, that's always your initial value, how much you start off with. Okay, so here's the part that everyone gets confused. Is it, so I know that 135% is 1.35, right? So it's not 135, we have to change it to 1.35. But my question is this, and this is what kids get confused with. Inside the parentheses, is it just 1.35 or is it 1 plus 1.35? It's 1 plus. Okay, some people think since it's already over 1, they're like, oh, just write it over 1, but it's not. You still have the 1 plus there. So it's 1 plus, and then your percentage, which is 1.35 to the t. So this is actually your function. Okay, it's okay to have a number in parentheses bigger than 1. You can have like a 7 in there, or a 10 or 1,000 or whatever. That's okay. That just means you had a huge percentage increase. So then they're going to say then, like, what is your A and what is your B? Like, what is the A in this equation and what is the B in this equation? Okay, so I think maybe the A is the easier one. So what number is the A? 50,000. Okay. So yes, the A is the 50,000. But I think what confuses you maybe is what is the B? Because like there was originally no B in this equation. Does anyone think they remember? This is like a long, long time ago now. What number do you think would be the B? Reed, is your hand raised?
Yeah.
What is it?
Is it 1.35 or is it 2.35?
I don't know. You tell me.
I think it's 1.35.
Does anyone agree or disagree or have something? So it's actually 2.35. So guys, your B, remember a long time ago when we first started learning this, we didn't have like the 1 plus in the middle. We had y equals a times b to the x. Does that ring a bell? A long, long time ago, you just had 2 numbers because we wanted to make it simple. So this b was essentially whatever was connected, right? So that's whatever was in the parentheses. So what's in the parentheses? Whatever 1 plus 1.35 is, which is 2.35. And that would be it. Okay. Last one. In exponential growth and decay functions, what happens to the function when the base of the exponent is greater than 1? So, for example, when the base of the exponent, so the base of the exponent would be like, what if I had like y equals 7 times, okay, so the base of the exponent, because it's to the x power, right? So give me a number bigger than 1. 2. So do you see how the base of the exponent, this is the base of this exponent, it is bigger than 1. So why don't we look? I don't know. I just made up a random number. So 7 times 2 to the x power. Let's look at that picture. So what happens if it is greater than 1? It would look like this. And then it says, how would it change if it were 1? So maybe how would it change if it were 1? Let's compare it if it is 1. And then the question says, and then how would the function change if the base of the exponent were between 0 and 1? So between 0 and 1, give me any number between 0 and 1. 0.5. Okay, so do you see what they're asking us to compare? They're asking us to make different numbers to the base of the exponent. If it's bigger than 1, if it is 1, if it's less than 1, but between 0 and 1. Okay, so let's see. If it's bigger than 1, it looks like this. Okay. If it is 1, then it looks like, so I just changed it to 1, it would look like that. And then if it's between 0 and 1, so we said 0.5, it would look like that. So does anyone think they can say overall what changes in each of the pictures? So this is if it's between 0 and 1. This is if it is 1. And then this is if it's greater than 1. Okay, so what can we say? Right, but how? Okay, so how does the line get different? The rate of change, okay. Yes, the slope changes. So how does it look? Maybe instead of being so like technical, how did the looks of it change? Okay, so which one was straight?
1.
The 1, okay. So it's a straight line if the base is 1. Okay, so now maybe let me compare the other two. So this one I wrote first, and then second one is if it's less than 1. Okay. Oop. There. Okay. So, what did I do? 7 times, oh, thank you, I put 2. Yeah. Okay, so this is if it's bigger than 1, and this one looks like if it's less than 1. So how can I compare the two?
One's increase and one's decrease.
Yes, one is an increase and one's a decrease. So which one is the increase? The 2. So if it's bigger than 1, then it's a exponential growth. But if it's less than 1, then it's an exponential decay. Okay, that is it. Online kids, in-person kids.